For example 3, it says find the eighth term of the geometric sequence with a sub 3 equals 36 and a sub 5 equals 324. Let's just start from the beginning. We've got a sub n equals a sub 1 times r to the n minus 1 power. So we need to know the first term, we need to know the ratio, and we know neither of those. Nuts. Wait, there's an idea. Okay, what we can do is we're going to work with the terms that we have. We actually did something like this back when we worked with arithmetic sequences. We haven't thought about this process in a while, but we see if we can use this to help us refresh our minds. So we don't have the first term, we don't have the ratio, but we're just going to work with the first term that we do have. Now, instead of a sub n, I'm going to use a sub 5, our last term that we do have. Instead of a sub 1, because we don't know our first term, let's use a sub 3, because that's the first term that we do have. Now we're going to multiply that by the ratio. Again, we don't know that. We got to figure that out. And we're going to raise it to the, well, we replaced n with 5. Oops, sorry, I want to color code it this way. Minus, and it used to be n minus 1, and we replaced 5 with n. Flip that around, n with 5. But the 1 in the previous one got replaced with a 3. So instead of 5 minus 1, we're going to do 5 minus 3. This is going to help us figure out our ratio. Let's start plugging in those numbers. A sub 5 we know is 324 equals a sub 3, 36, times our ratio. Still don't know that. 5 minus 3 is to the second. Now we're trying to solve for r here. So we got 36 times r squared. We got to undo the order of operations, which means we got to work from the bottom. So like normally order of operations, you know, PEMDAS or GEMDAS, where we do grouping, exponents, multiplication, division, addition, and subtraction in that order. We got to work backwards. So we got to get rid of any addition and subtraction first, then any multiplication, division, then exponents, then groups. Well, we have 36 times r squared, so let's divide both sides by 36. Now, if you don't know what 324 divided by 36 is, that's perfectly fine, but it is not the worst of numbers, it's 9. So we got 9 equals r squared. Now, to solve for r, just like we did in, like back when we were doing quadratics, take the square root of both sides. The square root of r squared, remember square roots and squares cancel each other out. The square root of 9 is 3. But there's more. It could be plus positive 3 or it could be negative 3. We technically don't know. So say, for example, let me just take a sidebar over here, or up at the top here. Say we're at 36. That's our third term, a sub 3. A sub 5 is 324. Essentially, we have like a missing term here. That would be a sub 4, the fourth term. Now, we could do we should do our 36 times 3, which would be 108, and then multiply that by 3, would give us 324. That works. However, let me zoom in on this, sorry. So again, you can go from 36 to 108 to 324 by multiplying by positive 3, and you can get from the third step to the fifth step, no problem. But you could also do it where instead of multiplying by positive 3, you multiply by negative 3, and you get negative 108. Then you take negative 108 and multiply that by negative 3, and you get back to positive 324. So we technically don't know whether it's positive or negative. Rats. That's okay. We're just going to have to do the same thing twice. It's going to be okay. Trust me. So we're going to, off to the side here, create two separate examples. One where our r is positive 3, the other one where r is negative 3. We're asked to find the eighth term of the sequence. So we're going to do a sub 8 equals, we still don't know the first term. That's okay. Let's still work with the first term that we do have. We know a sub 3, our third term. And we're going to use the ratio 3 raised to the, just like we changed n to 5 earlier, we're going to change n to 8, minus 3. Again, since we're not using the first term, we're using the third term, it's going to be 8 minus 3. Still don't know what a sub 8 is. That's what we're trying to find. A sub 3, 36, times 3 raised to the 8 minus 3 power. Again, that's to the fifth power. I want to take a step back because I kind of glossed over this earlier. Thinking about these exponents here. These exponents are telling us how many times, how many steps it takes us to get from one term to the next. So to go from the third term to the fifth term, it took us 2 steps. Over here, to get from the third term to the eighth term, it would take us 5 steps. That's why we use that exponent. Okay, so a sub 8 equals 36 times 3 to the 5th, folks. I'm going to go on a limb and say most of us are just going to use a graphing calculator for that, or any calculator for that. And that's perfectly okay. We get 8,748. That's one of our answers. The other answer is going to be pretty similar, but let's see what's different. A sub 8 equals a sub 3 times, instead of 3, we're going to do negative 3 raised to the 8 minus 3. I'm overwriting things more than we really need to. So we got a sub 8. We've got a lot of this done already. We got 36 times negative 3 to the 5th. Plug that into a calculator. Again, making sure that negative 3 is in parentheses. We got a sub 8 equals negative 8,748. So one's positive, one's negative. What I don't want you to assume, however, is that if you end up with two different r values, the values will always be opposites. There are cases where they're not. Let me show you an example of that. Say I wanted to find the ninth term, a sub 9. So just kind of skipping some steps here, it'd be 36 times 3 to the 8th power, and that would give us a sub 9 equals 26,244. What if we were to find the ninth term of the other one, where we have an r of negative 3? We got a sub 9 equals 36 times negative 3 to the 8th power, and that gives us a sub 9 equals 26,244. They're both positive. So don't automatically assume, since you have two different r values, one's positive, one's negative, that they're always going to be opposite answers. There is a chance you'll get the same sign. For example, on our ninth term, we have the same sign. The 8th term, different signs. 9th term, same signs. Take a look at example 4. I would like you to try that one out on your own. There's some decimals in there. It's okay. For time's sake, I'm going to skip over it. I will post the filled-in version of the notes on Google Classroom. For time's sake, I'm just going to skip over it, because I want to take a look at the bottom part of example 4. It says find the indicated sum of the geometric series where it says k equals 1 going up to 4 of 3 to the k minus 1. Just to kind of refresh on a couple things here. This says start with your first term. Skipping letters again. Start with your first term. Stop at your fourth. So to find each term, we got to plug them into this. So we got a sub 1 equals 3 to the 1 minus 1, or 3 to the 0, which is 1. Second term, a sub 2 equals 3 to the 2 minus 1, or 3 to the 1, which is 3. A sub 4, nope, skipping numbers, sorry. A sub 3 equals 3 to the 3 minus 1, giving us 3 squared, or 9. A sub 4 equals 3 to the 4 minus 1 equals 3 to the third, or 27. So we're not asked to just find the terms. In a series, remember, we got to take those terms, add them up. So we have 1 plus 3 plus 9 plus 27. You can go through and just add these as is. 1 plus 3 is 4, plus 9 is 13, plus 27 is 40. Or if it helps you to pair things up, I know a lot of us think this way, 1 plus 9, that's 10. 3 plus 27 is 30. So we got 10 plus 30 giving us a grand total of 40. It does not matter what order you add them in, you should get a grand total of 40. I'm going to pause here and we're going to take a look at how to simplify this on the next video.